Hello, welcome back once again. Believe me, this integral looks so innocent, right? But it is a little bit tough. But in this video, we're going to evaluate this nice looking indefinite integral, right? The integral of square root of 1 plus x divided by 1 minus x dx. So let's get started. This integral, let's call it I. Then I is same as the integral of square root of 1 plus x, then divided by the square root of 1 minus x dx. Now we're going to make the following substitution. We're going to let the square root of 1 plus x equals t. Square both sides, we get 1 plus x is equal to t squared. So for x, x is equal to t squared minus 1. Differentiate both sides, we get dx is equal to 2t dt. So here I is equal to the integral of, up there we have just t, because that is the square root of 1 plus x. And here divided by, this is the square root of 1 minus x, check it out, is going to be 1 minus t squared minus 1, which is same as t squared minus t squared plus 2, right? So this is 2 minus t squared. Then dx is 2t dt. Take the 2 outside, we get this equal to 2. The integral of t squared up there, then divided by the square root of 2 minus t squared, and here we have dt. Now we're going to make the following nice trigonometric substitution. So we're going to let t equals root 2 sine of theta. So here the t is equal to root 2 cosine of theta d theta. Okay, so here I is going to be equal to 2. The integral of t squared is going to be root 2 sine of theta squared. Okay, so here divided by, this is square root of 2 minus t squared is root 2 sine of theta squared, right? Then dt is equal to square root of 2 cosine of theta d theta. Okay, so now from here, I is equal to 2, the integral. So up there we have 2 sine squared of theta, right? Then divided by, this is square root of 2 minus, that is 2 sine square of theta, and then root of 2 cosine of theta d theta. So this is equal to 2, the integral. So up here we have 2 sine of theta squared divided by, so in this radical we're going to factor out 2, then into bracket 1 minus sine of theta squared, right? Then root of 2, sorry for that. So we're going to have root of 2 cosine of theta d theta, right? So here root of 2 cosine of theta d theta. Okay, so now from here I is equal to 2, the integral. So here we have 2 sine squared of theta, then divided by, this is going to be same as square root of 2 multiplied by the square root of 1 minus sine squared of theta, right? Times square root of 2 cosine of theta d theta. So this is equal to twice the integral. So here we have 2 sine squared of theta, then divided by, so this is going to be square root of cosine squared of theta, right? Don't forget this root 2 gets cancelled with this root 2. Here we have cosine of theta d theta. So here I is equal to, this will be 4, the integral. So here we have sine squared of theta divided by, this will be cosine of theta here, multiply the cosine of theta d theta, and this both get cancelled, and here we have 4 integral of sine of square theta and then d theta. Okay, that's cool, right? So from here, let us recall that the sine squared of theta is going to be equal to 1 by 2 minus cosine of 2 theta divided by 2. So we're going to use this nice identity, okay? And if you multiply by 4, remember we have 4 there, right? So everything will turn out to be 2 minus 2 cosine of 2 theta. So therefore I is equal to, that will be the integral of 2 d theta minus the integral of 2 cosine of 2 theta d theta. So here this is giving us 2 theta minus 2 the integral of cosine of 2 theta d theta. For the integral of cosine of 2 theta, we can make a substitution letting 2 theta equals x, and from there we know the integral of cosine of theta gives the sine of theta, and blah blah blah. We have to cancel out the 2's, and finally we just have the sine of 2 theta. So therefore here I think I'm going to make that substitution for everyone to understand what I actually mean, okay? So this is what I actually mean. If you let 2 theta equals, let's say we have to let it t, or should I use, no, let's use y. We've already used t, so y, you see theta is equal to dy. Oh, sorry. What rubbish am I writing? So y over 2, right? So this is going to be y by 2. Then this implies that the theta is going to be equal to dy over 2. So therefore I will be equal to 2 theta minus twice. This is the integral of cosine of y multiplied the theta is dy over y over 2, I mean. So over 2, these 2 get cancelled with these 2, and we have to integrate the cosine of y, which is giving us the sine of y. So we have 2 theta minus sine of y plus c, and this is giving us 2 theta minus, is that sine of, okay, yeah, so minus sine of y, which is same as 2 theta, right? Because that is for y, and then plus c. So from here we need to simplify a little bit. This is I is equal to 2 theta minus, now sine of 2 theta is same as 2 sine of theta cosine of theta, and then plus c, right? Okay, so what is our theta? Let us recall that t is equal to root of 2 sine of theta, and we know t by root of 2 is giving us the sine of theta, and we can see sine of theta is located here. So take the inverse sine on both sides. We see theta is equal to the inverse sine of t by root 2. But from here we can go ahead and square both sides to solve for cosine of theta, right? That gives t squared over 2 is equal to sine squared of theta is 1 minus cosine squared of theta, and from here we see that the cosine squared of theta is equal to 1 minus t squared by 2, and simplify properly, and you see cosine of theta will be the square root of, this will be 2 minus t squared all over 2. So here I is going to be equal to 2 theta is going to be 2 inverse sine of t by square root of 2, and then minus twice times, then sine of theta is that is going to give us t by root 2, right? So t by root 2 multiplied by cosine of theta is, we can do it as square root of 2 minus t squared divided by square root of 2, and then plus c. Now here square root of 2 times square root of 2 is 2, and this get cancelled with this, right? So we have I is equal to 2 the inverse sine of t by root 2 minus, here we have t square root of 2 minus t squared plus c. Then we need to recall again that square root of 1 plus x is equal to t. Therefore I is equal to 2 the inverse sine of t, oh, no more t again, so that's going to be the square root. of 1 plus x divided by the square root of 2, which can be written as square root of 1 plus x divided by 2, just like this, okay? Then minus, this is square root of 1 plus x multiplied by the square root of, now 2 minus t squared is going to give us 1 plus x. So 2 minus 1 plus x is giving us 1 minus x and plus c. We can multiply the radicals together. We finally get 2 inverse sine of square root of 1 plus x divided by 2 minus square root of difference of 2 squared. That will give us 1 minus x squared, and hence plus c. So this right over here is our final answer. Thank you for watching. Please, if you really enjoyed the video, kindly subscribe to my channel. Also like, comment, and share.